أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي ربي زدني علما وارزقني. Assalamu alaikum warahmatullahi wabarakatuh and good morning, good evening, good afternoon. So today in this class we are going to discuss regarding the grade 10 unit number 4, that is Newton's law of motion. So that is our grade 10 second physics part, right? So already we have discussed grade 10 unit number 2, that is the first physics part, and this is our second part, Newton's law of motion. Okay. So in this lesson we are going to discuss regarding the laws related to the force and what is momentum and what is mass and what is weight. These are the content. Three laws of Isaac Newton, sir, and momentum and regarding the mass and the weight. Okay, these are the things that we are going to discuss in this class. Okay. Now we'll start the class with the question, what do you mean by force? Okay, already from your grade 8 and grade 9 and grade 7 we are starting regarding the force, right? Force means simply we can say push or pull. During lifting or compression we are applying the force, right? So simply we can say force means push or pull is called as force. Okay. So Isaac Newton is a scientist. He has stated three laws related to the related to the force. So the first law, the Newton's first law, we are going to discuss now. So here, before discussing Newton's first law, we have break down the Newton's first law into two different parts. So it will be easy to understand the Newton's first law, right? So we have break down the Newton's first law into two different parts. Okay, not two different parts, two parts. Okay. First thing here, just look at the diagram. Here we have taken a ball here, right? Until you apply the force, what will happen? The ball will be at rest. Am I right or wrong? After applying the force, ball will start to move. Okay, fine. But until you apply the force, what will happen? The ball will be at rest, right? So Newton said that until an unbalanced force is applied, the body is at rest, will be at rest. Until the earth end, the body will be at rest until you apply the force. But after applying the force, the ball will move. But until you apply the force, the ball will be at rest. Nothing will happen to the ball. Same like that here, Puller. Look at the trolley here. Until you apply the force, trolley will be at rest. The trolley will be at rest until you apply the force. After applying the force, it will move. But until you apply the force, the body is at rest. The bodies which are in rest without moving, it will be rest until we apply the force. Okay. And here second part. For example, just look at the diagram. Here we have taken a ball here. The ball is moving towards the goal post, right? So if the goalkeeper didn't apply the force, until he applied the force, what will happen to the ball? The ball will be moving with the same velocity. But after applying the force, the ball will be stopped. But until he apply the force, until he catch the ball will move with the same velocity. Without anything, the ball will move with the same velocity. Am I right? Here we have the ball here. The ball is moving toward the goal post. Okay. If he stop the ball, if he catch the ball, definitely the ball will be stopped. Okay, fine. But until he apply the force, until he catch the ball will move with the same velocity. Am I right? Or if the ball is moving with 100 ms minus 1, yes, it will move with the 100 ms minus 1 until he apply the force. If he catch the ball will be stopped. So that is Newton's second part. The first part, the Newton's first law has been divided into two parts, right? So second part, that is until an unbalanced force is applied, the bodies in motion, the bodies which are moving will move with the same velocity until you apply the force. But if you apply the force, the case will be different. Okay, now we'll combine together, right? Until an unbalanced force is applied, the bodies at rest will be at rest. The bodies in motion, the objects which are moving will move with the same velocity. This is Newton's first law. Okay. Now we are going to discuss some examples or some scenarios that related to the Newton's first law. Okay. Now look at this example, Pulahal. The box and the car, they are moving with the speed of 100 ms minus 1. We'll take like that, right? They are moving with the 100 ms minus 1. Here, there's a stone there. So the car will be stopped. Okay, what will happen to the box? What will happen to the box? If the car stopped, what will happen to the box? Will that box stop the motion? No, right? The box will never stop the motion. The box will move with the same velocity. It will move with the velocity of 100 ms minus 1. So, but it seems to be that the box is going to jump, right? Jump out of the box. Actually, no. The box is not jumping. We didn't apply any force to the box. The box is moving with the same speed. Right? The Newton said that until the force is applied, the bodies in motion, the bodies who are moving, they will move with the same velocity. Nothing will happen. Nothing will happen to that box. Even the car is stopped. Nothing will happen to the box because we didn't apply any force to the box, right? The box was moving with the 100 ms minus 1. Now also the box is moving with the 100 ms minus 1. And now look at only the box. Just forget the car. Just forget the car and look at the box here. Now forget about the car. Now forget about the car. Now just look at the box here. Box is moving with the speed of 100 ms minus 1. Okay, it's moving. Moving. Okay, moving. Okay, still it is moving. That's all. Now just forget the car. There's no need to worry about the car. Now you want to look after only the box. Newton said that until an unbalanced force is applied, until you catch this box, until you stop the box will move with the same speed 100 ms minus 1. Newton's first law, the scenario. In the exam, they will ask, right? Okay. Very familiar one, that is this one. When the car, for example, just if the driver and the car is moving with the speed of 80 ms minus 1, for example, just say both of them are moving with the speed of 80 ms minus 1. Okay. When the car suddenly stops, what will happen? The car will be stopped. The passenger will move with the speed of 80 ms minus 1. But if you apply the force, if anybody catch the passenger, if you are wearing a seat belt, then it will be protecting you. But if there's no seat belt, he will continue to move with the speed of 80 ms minus 1. Same like the box in the car. Look at this example. Okay, here the bike and the bike rider was moving at the speed of 80 ms minus, for example, we'll take like that, right? The bike stopped. Okay, fine. But the passenger, but the biker, the traveler will move with the speed of 80 ms minus 1. Until you catch that passenger, until he falls down, he will move with the speed of 80 ms minus, because Newton said that until an unbalanced force is applied, the bodies in motion, the bodies which are moving will move with the same velocity. Right, okay. Now we have discussed Newton's first law and the examples that are related to the Newton first law. Look at this example. The passenger and the bus is moving here with the speed of 100 ms minus. We'll take like that, right? Okay. When the bus stop, okay, the bus will be stopped with motion, but the passenger, he was moving with the speed of 100 ms minus 1. So he will continue the motion with the speed of 100 ms minus 1 until when? Until anybody apply the force, or until he hits that seat that in front of him or whatever. So he will move with the 100 ms minus speed, 100 ms minus speed forward along with the bus. Bus got stopped. Okay, fine. Because earlier the bus and the passenger were traveling with the speed of 100 ms minus 1. The bus got stopped. The passenger is still moving until the unbalanced force is applied. Until anybody catch him. Until anybody catch him, or until he apply the force in any other object, he will move with the speed of 100 ms minus 1. Same like the box. The box and the car was moving. The car got stopped. The box, it was not jumping forward. It was not jumping. It was moving forward with the same speed. Same like that. The passenger will move with the same speed of the bus 100 ms minus 1. But already the bus has been stopped. The bus has stopped. The passenger is moving forward with the speed of 100 ms minus 1. No one applied the force. No one didn't push him back. Oh, no one push him front. Nobody applies the force in this passenger. The passenger is moving. Nobody apply the force on this passenger. You want to keep that in your mind, okay? In the exam, they will ask, the passenger will move forward when the bus got suddenly stopped. By using which law it can be explained? You know, by using the first law. Okay. Now we are going to discuss our Newton's second law. Okay. Okay, same like Newton's first law, we are going to break down the Newton's second law into two parts. Same like the Newton's first law, we're going to break down Newton's second law into two parts, right? Okay. Before moving to the Newton's second law, I want to explain what is directly proportional and what is inversely proportional. Try to get the idea. Well, directly proportional. Okay, listen here. When you're eating more and more and more, what will happen to the size of the body? The body size also will increase, right? So when you're eating less, what what will happen to the size of the body? So it will also will become less, right? So here I will say eating is directly proportional. If you are eating more, the size of the body also will be more. If you are eating less, size of the body also will be less. So this is called as directly proportional. Eating is directly proportional to the size. Did you get the idea? What is the meaning of directly proportional? Okay. Now I'm going to explain what is inversely proportional. Look at this example. When you are doing more exercise, what will happen to the size? When you are doing more and more exercise, size will become less, right? Size will become decreased. And when you are doing a very low amount of exercise, when the time that allocated to do the exercise becomes less, what will happen to the size? Size of the body will increase. So this is called as inverse. Vice versely proportional. It will happen in the opposite way. When the exercise increases, size of the body decreases. When the exercise decreases, size will increase. This is called as inversely proportional, vice versely proportional. So I hope that you may have got the idea what is inversely proportional and what is directly proportional. Okay. Now look at this example here. Here the force is low, right? Here force is low. And here force is high because here three persons are applying the force. So here force is high and here force is low. If the force become less, what will happen to the acceleration? Will the car accelerates very quickly? No, right? So acceleration will be low. The velocity will be very, very low when the force is decreased. But when I increasing the force, when three of them are applying the force, what will happen to the acceleration? Acceleration will increase. Did you get the idea? If the force decreases, acceleration also decreases. If the force increases, acceleration will increase. So this is called as directly proportional. So I will say acceleration is directly proportional to force. Why? If the force increases, acceleration increases. If the force decreases, acceleration also decreases. So force is directly proportional to acceleration. Now you know the meaning of directly proportional, and now you may have got the idea how did I link the force and the acceleration. The force is directly proportional to acceleration because you know if the force got decreased, acceleration also will get decreased. If the force increases, acceleration also will increases. And second part, look at this example here. Here, which in case A or case B, in which time the acceleration will be high? When the mass is low, the acceleration will be high, right? If the mass is very, very high, what will happen to the acceleration? The velocity will be very, very low, right? Okay. Look at this example. When the velocity will be high, Puller, when you are pushing a small car or a big car, here the mass is low, so the acceleration will be high. Here the mass is high, the acceleration will be low. So this is called as what, Puller? Directly proportional or inversely proportional? Which kind of proportion is this? This is inversely proportional. Now you may have got the idea. Acceleration inversely proportional to mass. Acceleration inversely proportional to mass. So same like that here. Now we'll combine the first part and the B part together. Now we will get the total Newton second law. Here the acceleration is directly proportional to force. You know, when you are increasing the force, the acceleration will be high. In that car, you know, when one person applying the force, the acceleration is very, very low because the force was low. But when more number of persons are applying the force, what will happen to the acceleration? When the force increases, acceleration also will increase. So force and the acceleration, they are directly proportional. Inverse, what is inverse? It happens in opposite way, you know, right? When the mass got increased, acceleration decreased. When mass become less, acceleration become high. So this is called as inversely proportional. So acceleration and the mass, they are inversely proportional. So when you are joining these two together, you will get the definition, you will get the Newton second law. Okay, now we are going to discuss a very important part, that is the equation that is related to the Newton second law. That is force is equal to mass into acceleration. Okay, now we'll do some example, will some calculation related to this equation. Okay. Okay. Question number one. Okay, question number one. An elevator of the mass that is 800 kilograms is accelerating upward towards 1.5 ms minus 2. What is the force applied by the accelerator? That is a question. Right? For example, just say, you know the equation that force is equal to mass into acceleration, right? Okay. Mass into acceleration. You know the mass. You know the mass that is 800 kilograms. And you know the acceleration that is 1.5 ms minus 2. Acceleration is measured in the equation F is equal to mass into gravitational acceleration. So mass that is 800 kilograms, acceleration that is 1.5 meter second minus 2. So we are going to multiply the mass and the acceleration. Now we will get the force that is 1200. What will be the unit, Palahal? We can put the unit kilogram, this kilogram, and this meter second minus 2. Okay, fine, that is not wrong. But if they are asking standard international unit, you can't say this answer. You want to say 1200 Newton, because Newton is the standard international unit. Kilogram meter second minus 2 is the fundamental unit, that is not the SI unit. Okay, now we'll do some other example related to the Newton's first law. Okay, we'll do some examples, right? Okay, so look at this question here, you know, before listening to this question, right? So before I'm explaining this question, you want to do the question, right? You want to try this question. So after trying the question, you want to try, first of all, you want to try to get the answer. So if you're not able to get the answer, then only you want to watch the video, right? So now stop the video and try the question and now continue the video. Okay, right, now we'll start the lesson, right? Okay, force is equal to mass into acceleration. You know the mass, that is 7.5 kilograms, and the acceleration, that is 4 meter second minus 2. So when you're multiplying these two, you'll get the answer 30 kilogram ms minus 2. We can put like that, but you know the standard SI unit will be 30 Newton. This is the way to do the question, right? Okay, now we'll do question number 30, a very good same question, right? Just you want to put the equation, my dear. Just you want to put the equation first. I hope that you can watch the video, right? No. Okay, right, sorry. So now I think okay. So here, Pulha, listen here. Force is equal to mass into acceleration. You know the mass, that is 5 kilograms. Okay, just substitute the values. And acceleration, that is 2 meter second minus 2. Okay, and you know what to do, right? You want to multiply these two values, so you will get the answer 10 kilogram meter second minus 2. And you know there's no need to put 10, right? You can directly put 10 Newton, right? And question number 14, it's little bit different, right? So in this question, they are asking the acceleration. They have given the mass and the force, and they are asking the acceleration. A little bit different question, but not that much hard. Okay, first of all, try the question. If you are unable to answer the question, then watch the video, right? Before listening to the answer of this question, please try those questions. Then after trying, we can continue the video. So for these kind of questions, there's no need to be worry, okay? There's no need to be tension, right? First of all, put the equation force equal to mass into acceleration. And you know the force, that is how much, plus? The force is 20 Newton, okay? 20 Newton. Just substitute the values. Mass, that is 5 kilograms. You don't know the acceleration. So if you want to find the acceleration, what will you do, Pulahal? What will you do? You will bring this 5 here, right? So 20 divided by 5 will be equal to A, that is 4 meter second minus 2. This is the way how to do the question. Okay, question number 15. Okay, same. Okay, it is very easy, right? Force is equal to mass into gravitational acceleration. The mass, that is 1000 kilograms. Acceleration they have given here 2 meter second minus 2. So answer will be 2000 Newton. Okay, so I hope that you have got the idea how to write the equation and how to substitute the values and how to get the answer. Now we are going to discuss Newton's third law. Okay, very easiest to law, right? There's no need to worry about this one. Very easy when you're comparing the previous laws. So Newton's third law, he says that each and every action has equal and opposite reaction. Look at this picture below. There's a runner, there's an athlete, right? So he's going to apply the force on the surface. And what will happen? The surface will apply a equal and opposite force. If he apply 100 Newton, the surface also will apply 100 Newton. If he applies 100 Newton, the surface also will be apply 100 Newton in opposite direction. Okay. Look at this example. When he is swimming, what will happen? He will push this wall. The wall will push him back. So this is action. He is applying the force, right? So that is action. And again, what will happen? The wall will push him back. That is reaction. Right? Okay. Look at this example. So during swimming, what will happen? The swimmer will push the water. The water will push him forward. Newton's third law. Newton's third law. He will apply the force on the water. He will push the water. The water will push him forward. Newton's third law. This is action. He is applying the force. This is action. The water will push him forward. That is reaction. Look at this one. So when you're walking, you will apply the force on the surface. The surface will apply the force back. So you will be moving front. Newton's third law. This is action. And this is reaction. Equal and opposite reaction. When you apply 100 Newton, the surface also will apply 100 Newton. Most of them have a doubt, right? And do we apply a force on the surface? If you have a doubt like that, right? Okay. Well, just try to get the idea. When you are working, how do you work? When you are working, how do you work? Right? You will be moving like this, right? You will be rough. Will you move like this by taking the leg like this? No, right? So you will push the surface and the surface will push you back. You are not walking like this, like a cat. You are not walking like this, right? By taking your legs like this. No, you will push the surface and the surface will push you back. Now there must be no any doubt in that case, right? So you are applying the force on the surface will apply the force you back and you will be moving forward. Okay. And look at this one. These are the examples related to the Newton's third law. Frequently they will ask by giving this picture. In the balloon will apply the force downwards and the air will push the balloon upward. This is action and this is reaction. Okay. And in the rockets, the same thing will be happen. Even in the when you're shooting in the gun, right? Okay, wait a minute. So these are the examples that are related to the Newton's third law. Look at these pictures, right? So the balloon will push the gas downwards and the gas will push the balloon upward. This is action and this is reaction. And in the example, normally they will ask Newton's third law and they will ask what are the examples or what are the scenarios that can be explained by using the third law. In the MCQ, frequently they will ask. Look at this picture here, Bulahal. Here you know the gun will push the bullet forward. When the gun pushing the bullet forward, the bullet will push the gun back. That's why they will give the support in the shoulder. You may have seen this one, right? Even in the camping and all, when you're shooting the gun, when you're shooting, what will happen? The gun will be moving backward because the gun will push the bullet forward and the bullet will push the gun back. When you're keeping that one in your face, what will happen? The face will got damaged. That's why you're supporting by using your shoulder. So this is third law. This is action. The gun pushing the bullet, that is action. And bullet pushing the gun back, that is reaction. So now you may have got the idea what is Newton's third law and what is action and what is reaction. Look at this picture here. In the boat, you will apply the force, right? You will push the water backward and then you will be moving forward. This is action. The water will push you forward, that is action. Am I right or wrong? If you want to back, what will happen? You will apply the force front. You will push the water and you will move back. Am I right? If you want to move backward, what will happen? What will happen? If you want to move forward, you will apply the force in this direction and you will be moving here. But if you want to move back, what will you do, Bulhar? If you want to move back, you will apply the force in this direction and you will be moving in this direction. Am I right or no? If you want to move back, if you want to move forward, you will push back and the water will push you forward. Newton's third law. This is action and this is reaction. Did you get that idea? Every action has equal and opposite reaction. This is Newton's third law.